All right, well, let's get started. Welcome to my presentation today on demystifying artificial intelligence and its use cases. My name is Adam Dzaki. I'm the product manager here at Cyerson. And before we really get into things, just one housekeeping item that you're going to see throughout the rest of the day is that all of our sessions are being recorded. And all of them will be available following the event today. There is 30 minutes of Q&A dedicated after each and every single session today. So if you have questions about something you see, something on your mind, you can find me and others there to answer those questions. And last but not least, our open floor is open the entire day. So if you have anything on your mind, whether it be around presentations, something you want to talk about, technical, whatever you want, you can find myself and fellow Cyerson employees there, along with other attendees. And you can swing in and discuss anything you want. So let's get into it. Just a little bit about me. For those of you that don't know me, I have spent the better part of the last probably like 10-something years now around automation focused with respect to PowerShell, System Center, Azure, and then, of course, just general process improvement. And it's within the last few years that I've become rather obsessed with applying artificial intelligence to some of those very processes that I previously automated myself. And with it has become this other intersection / obsession around not just the practical use cases of artificial intelligence, but also where and how that AI should be applied. Specifically the results that we get from our predictions and how to interpret those, how they have the potential to be misinterpreted, and what we can do to ensure that that does not happen. And my agenda today is actually pretty succinct. It's actually only 3 points. And I just, high level, what I want to go over here today is the automation spectrum, the different types of AI that you can encounter and you'll find out there. And then, of course, what are the use cases? What are the practical, down-to-earth use cases for AI with respect to service management? So to get started, let's talk about the automation spectrum. If you do a quick search on automation spectrum, you're no doubt going to run into some kind of flavor of this slide. And so by no means what I'm presenting here unique. It's probably going to have some flavor of this out in the wild. And the automation spectrum, as we go from left to right, moves from kind of manual, intense process building to more we're governing a decision-making process that something else is making, specifically a computer is going to make for us. So let's start with rules-based automation, because it's the thing I think that probably all the attendees today are familiar with. And I should add that it's something all attendees are familiar with regardless of your skill set, regardless of your technical ability, skill level, what have you. Because rules-based automation is probably most transferable to things like change requests, service requests, right? I have a review activity, I have a manual activity that kicks off a parallel activity. It may have some run books, it may have some manual activities in it, it may have some sequential activities in it. But it's very by the book, do this, if this, then that, right? And again, rules-based automation is very on the rails. Whatever you build, whatever you automate, whatever you create only knows how to handle those use cases. And if a use case arises that you haven't accounted for, it breaks. Or if you don't have error handling for it, it breaks, right? It's very kind of on the rails. But it's also very just programmatic in nature. It's if this, then that, right? And a lot of rules-based automation comes in the form of either scripting, some light scripting, or a drag and drop UI, similar to Orchestrator or Microsoft Power Automate, or other line of business applications you may be using to build some of those workflows and kind of rules-based workflows. Up next is RPA, which is short for robotic process automation, or probably the more colloquial term of screen scraping, right? With screen scraping, with RPA, with robotic process automation, comes the idea of if I don't have access to an API, if I don't have access to the underlying data, maybe the best and probably only way to integrate with that system is with RPA. And you can kind of consider this the last line of automation, in that it's the most fragile, but it absolutely works. It absolutely will get the job done. And again, this is for when you don't have access to the underlying data. So for example, let's say you need to provision a new user account on some third-party service that you use and they don't have an API. Well, it may be the only way to provision that account automatically is to screen scrape, to decide and define where the username field is, where the password field is, where the login button is. And again, with RPA, rather than scripting, rather than coding the RPA, we are going to record the process that we as a human would normally perform. What are the keystrokes that I type? What are the mouse clicks that I make? Where approximately is a button on the screen? And then click and perform those actions. You can think of this, again, just kind of like recording your steps and the computer plays them back. Just like rules-based, though, it's very on rails. Only in this case, it's slightly more fragile, because you can imagine if the UI changes, if an element on the page changes, the RPA breaks, right? And so there's still some rules-based that you have to introduce to handle those scenarios, prevent failures from occurring, et cetera, et cetera. But what I hope you can see is that RPA kind of builds on that rules-based automation, right? It's a different form of automation, but it still builds on the rules-based automation. And then up next is bots. With bots, we start moving away from being human-led and more to being human-supported, right? Because with a bot, think of like a chat bot or a bot that you visit on a website. The bot is going to respond to you based on the different inputs that you provide, right? Maybe if you ask a question, you'll get a different answer based on whatever that question was. But with a bot has the opportunity and the ability to maybe kick off an RPA, to kick off some rules-based automation. But again, it's going to do that based on the input that it was given. It is going to respond ever so slightly differently. But it's not sentient. It's not capable of true decisioning. It's kind of just making its best guesses. And again, it's probably best summarized as you'll get different output based on that different input, which is how we arrive now at artificial intelligence, how we arrive at AI, which is the furthest from being human-led, because now it's human-governed, it's machine-led. AI is going to make decisions for us based on the available data that we give it, that we teach it, that we show it. But again, we're only going to be now governing its decisions. We're just going to kind of be checking in to see that it's operating within the defined parameters that we set. And we just want to make sure it doesn't deviate. Otherwise, you got this. You're on your own. You can manage this. And obviously with AI, the goal here is to be completely, fully autonomous in decision-making and whatever paths that it goes down. But again, what's true in all of these cases, and I started with this slide with, is that every single piece of automation, every automation pillar, if you will, builds upon the previous. And in some cases, it may take advantage of the previous. So I want to be clear that as you move from left to right or right to left, you're not really, whole cloth just cutting over to something. You are building upon that previous pillar. And in some cases, if not many, you're going to be taking advantage of those previous pillars. So if you build some rules-based automation, don't think that when I get to RPA or I get to bots, I have to throw it out. Chances are you could probably recycle it, reuse it, and turn it over to that new service in some new and interesting way. But on the topic of artificial intelligence, on the furthest right on the automation spectrum here, with artificial intelligence, though, it's not just AI. And in fact, if you're looking really closely at this slide, you may go like, bots and AI sound pretty close. I'm having trouble splitting the hair here of how are these two things different? Because they sound a lot alike. Like, how is a chatbot different than AI? Isn't a bot using AI to determine how to give the right answer or do the right thing? And that really brings me now to point number 2. What are the different types of artificial intelligence? Because it's worth highlighting that even though we get to the furthest on the right, we get to AI, we get past bots, there's still different types of AI to use. And so the fine line that I want to split here, and again, this is pretty nuanced between that bot and that AI thing, is that we're really talking about the difference between cognitive computing and true artificial intelligence. Because cognitive computing is actually what's probably and typically associated with bots. With cognitive computing, we are attempting to emulate a specific human behavior, right? If I give a photo to a cognitive computing engine, it may describe that photo. Here's what's in the image. Here's what the image is about. Here's the colors that I found in that image. If I give it an audio file, it may translate the audio file from audio to text. Maybe I want to now take the text and convert it to a different language, right? Again, these are all specific human cognitive capabilities that when you add them up, start moving you towards some degree of artificial intelligence. Not full sentience, though, right? Again, like when we talk about AI, like true AI, that's sentient behavior. It's acting on its own. It really doesn't need our input. We would be able to converse and talk with this. So, it's a fine line to split, but it's one I think that is easy to make once you start understanding the difference here. But maybe another way to look at this, and probably a better way to look at this, honestly, is really cognitive computing is building the pillars to get us to AI, right? We're going to use different cognitive capabilities to get to AI. We may not use all of them. We may use some of them. We may use only one of them, right? It depends. It's going to vary a little bit here. But with cognitive computing, again, going back to the example I described with like an audio file, right? I get an audio file. I understand it and I can turn it into text. That text I can then turn into a different language because I'm just translating, right? Again, what I'm describing there is a couple different cognitive capabilities, and you can see them here as well, right? I have a speech cognitive capability to understand audio. I have a language cognitive capability to translate words from one language to another. Again, with vision, I could describe an image, what's in the image, the colors in the image, et cetera, et cetera. So now with that said, with that type of, that fine line split, the next question that may come up, and you may see or you may hear about, is, so then what's machine learning? Where does that get thrown into all of this? Because I heard rules-based automation, I heard RPA, bots, I got to AI, but then AI, kind of splintered out into like, cognitive versus true AI. And then there was cognitive abilities that got me to AI. Where does machine learning fit into this? How does that puzzle fit in? Or how do these pieces connect better said? So with machine learning, we're allowed to feed a computer a data set. And by data set, I want to be clear, that data set could be a CSV. It could be the output of a SQL query. A data set could be a folder of a bunch of images, a bunch of audio files, right? Data set is intentionally vague here because it could be any of those things. And depending on what they are, may lead me to choose certain types of ML. And speaking of that, there's a couple different types of ML, and specifically the ones that if you were to go look in Azure at the types of machine learning that are available, these are the ones that you'd see. You'd see classification, clustering, and regression. And they're split, I'd like to think makes quite a bit of sense. Classification, well, is this an apple? Is it an orange? Is this a pen? Is this a pencil? Is this an incident? Is this a service request? These are ways to classify certain things. With clustering, we're talking about groups, and specifically, what do groups have in common? What do groups overlap with one another? And the best example that I and probably many tend to give here is imagine watching your favorite streaming service. What do these certain television shows and movies have in common with one another? Do they share genres? Do they share a viewer age specificity, right? What is the overlap between these different groups of media? And finally, with regression, we're trying to predict a numeric outcome. We're trying to predict the price of something. We're trying to predict the quantity of something. We're trying to predict the volume of something, right? How many animals are in a certain population, how many people live in a certain area code given other area codes, or the state, et cetera, et cetera, et cetera. So then, with that said, the question that now comes up and inevitably will arise is, well, okay, I think I get these concepts. It makes sense. Why would I use this? More importantly, where would I use this? In fact, how would I make the distinction between what I need to build a report for versus what I should predict? That's why I wanted to create a slide here that gave some practical examples between the split that I want to make. These are examples of a couple queries that you may be used to in Service Manager. You may have asked, someone may have asked you, you may have written, right? Maybe I want to see the average survey score for a department. Well, that's easy. Just get all the incidents or get all the service requests, the affected user, the department, get the score, average it out. There it is, right? That's just the score. Billable time per analyst, pretty easy. Get all the work items, get all the analysts, get the assigned to, see what people worked, add that time up. That's their billable time. Assets with the most incidents, right? What are the hardware assets? What are my inventory that have the most number of incidents associated with them, right? Those are queryable things. That's data you can just get right now. But those same queries, though, on the other hand, are potentially the training grounds to move into AI. And that's why I wanted to give kind of the contrast of both of these, is because those very same queries, that very same data set I could potentially use to start making intelligent predictions about my environment. So again, I could get the average score of a survey for a department in a given month. But I also could say, I want to rate the sentiment of the comments that are being left, of the incidents that are being created. And from that, I want to weigh the sentiment against the survey score, or I want to see the sentiment change over time, if at all, given a certain type of work item or certain classification or certain, et cetera, et cetera. With work effort per analyst, right? Right now, you could be saying, I need you to enter your time on work items. And then you add it up at the end of the month and you look. But again, it could be interesting to say, well, what if you didn't have to enter your time anymore? What if, based on the time, or based on the volume of work, based on the number of things you're resolving, based on the number of things you're completing, activities that you're finishing, approving, etc., could I estimate the amount of time that you will work? Can I guess if you'll be overtime, undertime, or right on time? Is there a way to better plan around what projects I have to do next month or this year based on the current work volume? Is there a way to predict that time instead of having to have someone enter their time manually? And finally, and this is the one that I think is the most interesting, but I want to be very clear, I think they're all interesting, is when should I perform preventative maintenance, right? That's a really interesting, well, not just problem to solve, but it's also a really interesting, solution to pursue. I could be very reactive and total my incidents per asset, per month, per year, per quarter, etc. Or I could use that very same data, in addition to maybe a couple other data points, and say, this is when I should perform preventative maintenance to ensure that those incidents do not occur. Again, super interesting. What if I could prevent the work from even occurring in the first place? What if I could use that to better allocate and predict what my work effort per analyst should be for the next week, month, year, quarter, etc.? So you could see how maybe writing queries bleeds into making predictions, but you can now also see how some of those predictions also now start playing into themselves and playing into each other. So let's get to some use cases. Let's talk about the use cases for AI, because I've already given you a few, and I think you probably should get a sense of maybe where this is going. But if not, let's turn laser focus onto service management and artificial intelligence. So here's a couple use cases that I threw together. And they're around, predicting categories, the prices of things, maybe the contents of things, right? Again, these are some of the examples that I've kind of been alluding to previously in some of the previous slides. And I want to pick a few of these and go at them in a way that, again, I think is practical, it makes sense, and you can start using right now if you wanted to. So use case number one, I want to gauge the sentiment of someone leaving a review. Now, if you'll recall at Innovate last year, we introduced the Cloud Connector, and with that, we started weighting what is the sentiment of a incident's title or an incident's description, right? And we were recording that, and we were using that to score, again, what is the sentiment? Maybe there's an interesting trend to observe between what is the average sentiment over time. So with that, we started building a dashboard. We said it would be interesting to see what this looks like. And we built that dashboard on a scale of 0% to 100%. Now, sentiment scores are typically 0 to 1, but I've made it 0 to 100% just because I think it's easier to understand. Scores closer to 0 are negative, and scores closer to 100 are positive. Now, the question that will inevitably arise on this slide is, what is this data that I'm looking at? I see some low scores, I see some high scores. What is this? So this is now the part where I get to say, boom, big reveal, because this is actually a random sampling of all the comments left on every single work item on our portal since last year. So every single comment, every single interaction that we have had, our personnel included, we have actually been capturing and scoring the average sentiment of. Now, I want to be clear here that the data that we're using, one here is clearly anonymized. We have removed any, identifying information. But I also want to be clear here that the data in this case could probably lead you to some maybe false conclusions, some good ones. Maybe this could go a bunch of different ways. Specifically, are our lowest scores poor customer service? Are our highest scores glowing reviews, right? But what this may lead you to, and this is something that I heard since last year when we were showing some of the sentiment scoring, is I began to see that some people started taking this data at face value. They began to say, some people are just angry. Some people are just happy. Some people are neutral. They're right in the middle. They're always, they shoot straight, right? And I want to be clear that that's potentially a dangerous area. That's a dangerous path to walk down. And the reason is because if you take this at face value, in my opinion, which I'm going to argue here very shortly, it possibly sets up a dangerous precedent because we lack context. What is the context of the comment? What is the everything else that's going on with that work item, right? And again, I wanted to pose these questions because they're ones that I think you could find yourself in if you wanted to pursue sentiment analysis with respect to service management. Because when we look at our lowest scores, for example, less than 1%, less than 3%, less than 4%, it would be easy to say that person is just super angry. They're not happy. They don't like what we're doing. Could be true, but what's the lowest score given the work item type? For example, are those scores on incidents or service requests? Is it on a specific classification of an incident? Is it on the specific resolution time of an incident? What is the context of that negative score? The same is true on the inverse. What is the context of the highest score? Do people love us? Do they like the resolution time? Do they like the completion time? Are they happy with the product that they're referring to? Again, it can go a bunch of different ways. But the takeaway here is context matters. What does sentiment analysis tell us in relation to other data points? And that's what's really, I think, the important key takeaway here. Sentiment analysis is awesome. It's really cool. But you absolutely need to evaluate it within the context of that work item, of something else, of another data point. And to really drive this point home, what I wanted to do is actually highlight some rather questionable examples for Example, I really hate incidents unless they're automated. Thanks. I mean, I can't believe how long this took, but I know you're not the Postal Service. Thanks for getting into this so quickly. Now, I say these are questionable examples, and you may be reading them as like, they don't seem that questionable to me. But you have to ask yourself, are they not questionable because you heard me say them, or because you read them before you heard me say it? Because with each of these examples, there's some nuance, and I think I had some nuance when I delivered it. For example, I really hate incidents unless they're automated. Or I really hate incidents unless they're automated. Or I really hate incidents unless they're automated. There's a bunch of different ways you could interpret that, right? But it all depends on how you heard it. And so in the case of if we're running this through sentiment analysis, if we're running this through artificial intelligence and through cognitive computing, it's only going to read that text and then make a guess. It's going to score that text based on what it reads, and it's going to have to infer and assume some of the intent. And again, same thing for all of these examples for the other two, right? Again, this is open to interpretation. So what is the context of these comments being left? Certainly within themselves and within respect to the work item that they're on. And again, I just wanted to highlight this here again, right? Is this about all incidents? Is it about one specific type of incident from a specific source, a specific nature, a classification, a certain config item? How long this took, but I know you don't control the Postal Service. Well, is that about all of our new hardware requests? And, we're getting to them fine, but like the shipping delays are just through the roof or something. What was the actual completion time of that SR, right? Maybe you want to see what is the average sentiment against the average completion time of a certain type of service request. Again, context matters. We must always seek further context. And so it's really best summarized by this. This is what I would say around sentiment analysis if you're looking to pursue this, which I believe you should. I actually do think there's actually some real value in looking at sentiment analysis against these other data points. And it's pretty simple. Things you should do with sentiment analysis: view in relation to other data points. That could elicit some really kind of interesting observations on some interesting metrics. But things you should not do with sentiment analysis: you should not use it to compare or influence someone's behavior. For example, you should not say, why is Jim's score lower than Mary's? Why is Mary's score lower this week than it was last week, right? Again, you can imagine there's ways that you could use this, but ways that you probably shouldn't. And in this case, again, you should not use sentiment analysis in an attempt to compare two or more people, or influence two or more people, or certainly just one person. Two. Use case number 2. I want to parse documents, receipts, and invoices, right? I'm always getting a bill every month from my vendor. I'm always getting an invoice every time I purchase hardware. Well, if there's enough similarities in those documents, can I do something with that? I mean, or am I just filing that away? Or would it be interesting if I could do something with it, but I don't because it's time consuming. And so that's where Azure Form Recognizer comes into play. And I want to be clear here, I'm now kind of moving towards a specific AI tool set with respect to Microsoft and Azure, and that's their Form Recognizer, which allows you to submit a host of different forms, preferably of all this similar nature, and then it will extract data from those. And so in this case, what I've done is I've actually thrown up a couple invoices that I have, just some fake ones that I've thrown together. You see they have different line items, different values, et cetera, et cetera. And with Azure Form Recognizer, I can now point out where to find certain fields. I can name certain fields. I could say this is always a line item. Here's the name, the description, the serial, the price. Here's the company. Here's the receipt number. Is there a delivery video, et cetera, right? Now I want to be clear, to go back to something I said earlier. I said earlier RPA was emulating keystrokes and mouse clicks. And what I'm doing here is I'm clicking to show this is where you find these items. I want to be clear, those are not the same thing. You maybe theoretically could use the two together, but just try not to get these two confused for right now. So with Azure Form Recognizer, I'm just pointing out where to find certain elements of the document on the document, right? And if I submit enough of these forms, specifically, I think Microsoft's requirement is I have to submit at least 5 of a similar form, then I can start making analysis of those forms and extracting key value pairs. I can start extracting data from those forms. So the more forms I have, the better. Now, again, come back to what is a practical use case of this? What makes sense within the context of service management? Well, that's why I actually took these forms and I used them to automatically populate all of my invoices inside of Cybersyn Asset Management within respect to Service Manager. So every time I get an invoice in, I run this through Azure Form Recognition. It extracts those values. It automatically creates invoices within Asset Management. And you can see that I have invoice names, the receive date, the currency, the total amount, and I even attach the invoice to that invoice record inside of Service Manager. Again, I think it's a super practical and relevant use case. And so you can imagine, again, if you're ordering hardware, are the serial numbers on there? Could you potentially automatically provision a hardware asset in relation to an invoice that you get? So a lot of really interesting possibilities here as far as reading documentation and then pushing that data into Service Manager. Use case number 3. I want to predict the category of an incident. And this is something that I touched on last year with respect to a certain Exchange connector that allows you to predict whether something should be a service request, should it be an incident? What is the classification of that incident? What is the support group of that incident, et cetera, et cetera. I want to start predicting those data points. And the reason I want to predict those data points, the reason I want to predict those respective classifications is really twofold. One, I want to spare people from having to fill out what I'll refer to as the paperwork, which is picking the right category, picking the right support group, picking the right, et cetera, right? Filling out the paperwork of an incident. And two, I want to streamline my reporting. I want consistent metrics every time I report. And that's actually the example that I've given here is everyone can fill out an incident just kind of a little bit differently. And they're not wrong, but it's kind of subjective. It starts becoming open to interpretation, right? What person A may pick for a category may not be the same that person B picks out for a category. But if I were to use AI, if I were to use Azure machine learning and the classification algorithm, I could predict the classifications of incidents, or better yet, the type of work item that it should be. But to do that, I need data, right? Again, that should be the trend that you've gotten from this presentation and certainly the previous one is I need data to make informed guesses, informed decisions. So if you're reporting on categories right now, or if you have a query for categories right now, you've already got a head start. And if you understand that, well, the only reason we're picking the categories we are is because analysts are reading the title and the description and then picking the category on it, you kind of are already understanding probably one, where this is going, and two, how artificial intelligence, how machine learning is starting to make these predictions, right? It's doing it based on the data that it knows and that it has. And again, the last reason why you'd want to do this is because ensuring the consistency across your reporting is an adventure in time management on its own, right? You could pursue this, but maybe you could predict those categories and save yourself the time altogether. So I start with something like this, because whether you know or not, hopefully you do, pretty sure you do, Service Manager has a lot of data points. There's just an infinite number of data points across Service Manager. The title, the description, the classification, the first response date, the first assigned date, the first acknowledgement date, the created by user, like just data points all over the place. But I don't need all of them to predict a classification. I don't need all of them to predict the category. So it's probably not the best example. That's probably much closer. I really only need the title and the description and the category that a work item ended up in to start making these predictions. And in fact, I may want to go one step further. I may want to say, only get me the ones that are closed, right? Because I know those are not changing, right? Someone could theoretically change the classification before that work item gets resolved or before it gets closed, right? So maybe there's a way to tighten this query up a little bit before I go train and teach machine learning based on it. But again, the takeaway here is I need data. I need volumes of data. The more that I have, the better informed decisions that it makes. The less that I have, the less accurate those predictions are. Same thing is also true for the quality of the data. Someone, you may say like, well, my classifications are all over the place, or yeah, they're not this or not that, right? Well, you got to start somewhere, right? And so you could start trying to reshape some of those classifications, or you could just train on what you have and then kind of see where it goes from there and start using that as an opportunity to retrain your own service desk, right? If machine learning were to predict a wrong category, you could imagine, you could tell your service desk, like, I need you to be on the alert for this, because if it's wrong, I want you to correct it, right? And maybe, what's interesting there, maybe that's an easier exercise to do. Maybe rather than asking someone to pick it out of the gate correctly, it may be easier to say, correct it if necessary. And again, this is something you'd monitor over time and iterate and improve as predictions and data changes. But some things that you probably want to do with respect to this is if we're looking at the title and the description to predict the category, there's probably some words we don't really care about. In fact, we probably aren't really interested in things like the, a, be, aren't, are, they, et cetera, right? But with what's left, we then may start using the words that kind of frequently occur together to predict the category or to correlate a category based on a certain type or frequency of words that are used together. So I wanted to now get to this example because again, I wanted to go back to, it's, on a couple slides ago, this one, right? I had several thousand incidents. I know you can only see 24, but several thousand incidents. Here I only have 3. I probably wouldn't want to train on just 3 incidents, especially because there's only 2 categories used, and the third one I have no idea what it is. So the third one's also like bad data that I wouldn't include in a training set. But again, I want to come back to this because the more data I have, the easier it is to predict these values. And so an example of some of the incidents that I have that I wanted to pull from that data set just to show you is I have a title called printer issue, and then I have its description. I have Outlook on my laptop and its description. I have beeping and something with the internet. Now, again, you or I looking at this may go like, oh, the third one's easy. It's a networking issue, right? That's encompassing, it's vague, right? It could work, but that assumes a couple things. It assumes, 1, I have a networking category, and 2, I have sufficient data to train my machine learning to know when to predict a networking outcome. So again, all of this, every single part of this always comes back to data. If you want good form recognition, submit more forms. If you want good machine learning classification predictions, you need more incident data. You need more work item data. If you want more accurate sentiment analysis, you need to be looking at kind of this huge swatch of all data, so that you can look at those numbers in relation to other data points. And that's why with all of this set, hopefully this makes sense. Hopefully you can see where these practical use cases are, how they exist, how you can use them, how they certainly exist within the realm of service management. But I hope what you see more than anything is that while AI may seem magical, while it may sound magical or out there or too sci-fi, I want to be clear that AI is really nothing more than automating a task that you and I both currently do, which is we constantly reevaluate new information presented to us, we form new opinions on that data, and then we begin to make new decisions off of that data. And again, while we may not have the best data to start with, what's important is that we at least start somewhere to better inform those future decisions. So with all of that said, I hope this makes sense. I hope you learned something. If you have any questions whatsoever, I'm going to be available in the lounge immediately following this presentation. With that said, thanks for coming. Have an awesome rest of your day, and I'll see you in the lounge.